Hello students, our next lesson is about simplifying rational algebraic expressions. In simplifying rational algebraic expressions, it is very important to review the laws of exponents. First, the product of powers. If the bases are the same and the exponents are different, you just simply add their exponent. In this example, x to the 9th power times x to the 4th power is equal to x to the 9th power plus 4, which is x to the 13th power. Another example is m to the 10th power times m to the 4th power. Just simply add 10 and 4, so that is equal to m to the 14th power. Another law of exponent is the power of a power. In this case, you just simply copy the base and multiply the exponent. And that gives us the answer of a raised to 14. Another example is r to the 4th power raised to the 3rd power. So just simply multiply 4 and 3, and that is equal to r raised to the 12th power. Next is the power of a product. Example is quantity a to the 4th power times b to the 6th power, all raised to the 3rd power. You just simply multiply each exponent by the outside exponent. So that will become a to the 12th power, b to the 18th power. Another example is x to the 5th power times y to the 4th power times all raised to the 6th power. So we will distribute 6 to 5 and 4. Then multiply them. 5 times 6 is 30 and 4 times 6 is 24. Another one is power of a quotient. If the bases are the same, just simply subtract their exponent. That is r raised to the 6th power. Another example is r raised to the negative 9 power over r raised to the negative 3 power. We will interchange the two terms. The denominator will become the numerator and the numerator will become the denominator. And observe what happened to the exponent. They became positive. Then, apply the rule that we had a while ago. Subtract the exponent. You have to bring the answer to the term with the higher exponent. And since 9 is higher than 3, we will bring our answer in the denominator. So that is 1 over r raised to the 6th power. Another example is r to the 3rd power over r to the 3rd power. Since if we will subtract 3 by another 3, the answer is 0. And any number raised to 0 is equal to 1, or any variable raised to 0 is equal to 1. Another example, s to the 6th power over s to the 14th power raised to 0. As what I mentioned a while ago, any terms raised to 0 is equal to 1. How are we going to simplify? How are we going to determine if the given is a rational algebraic expression? A rational algebraic expression is a ratio of two polynomials provided that the denominator is not equal to 0. That is in symbol of P over Q, where P and Q are both polynomials. But the value of Q, the denominator, cannot be equal to 0. Let us determine if the following given is a rational or not rational algebraic expressions. Number 1, M is a polynomial, N is also a polynomial and not equal to 0. That means that number 1 is a rational algebraic expression. Number 2, the numerator is a polynomial. The denominator is also a polynomial. So number 2 is a rational algebraic expression. Number 3, the numerator is a polynomial. The denominator is equal to 0 because r cubed minus r cubed is equal to 0. So number 3 is not a rational algebraic expression. Number 4, the numerator contains irradical expressions. That means that this number 4 is not a rational algebraic expressions because of the numerator. Number 5, the numerator is a polynomial. The denominator is also a polynomial and not equal to 0. That means that number 5 is a rational algebraic expression. Let us now simplify rational algebraic expressions. Example number 1, 7x squared over 21x cubed. We will now bring the x in the denominator because 3 is greater than 2. So we have 7 over 21x cubed minus 2. We will cancel the common term from 7 and 21. Since the greatest common factor between 7 and 21 is 7, we have 7 divided by 7 is 1 and 21 divided by 7 is 3. So we have the answer. The numerator is 1 and the denominator is 3x because the exponent of x is x raised to 1 and that 1 is invisible. Example number 2. This time, we will first bring the variables on the variable with the higher exponent. M will be bring on the numerator, the N will be in the denominator, and the P will be on the numerator. So we have 25 M raised to 5 minus 2, P raised to 2 minus 1. And then in the denominator, we have P n raised to n minus 7. By simplifying, we have 25 over 5. The simplest form of that is 5. So we have 5 m cubed p over n squared. Next, number 3. We will first bring all the variables on the part where the exponent is higher than the other. So we have 8 times 3, which is the factor of 24, r raised to 4 minus 1, p raised to 6 over 8 times 2, which is the factor of 16, s raised to the 4th power minus 2. So let us now simplify. You cancel out 8 because that is common from the numerator and denominator. So we have 3r raised to the third power p to the sixth power over 2s to the second power. Another example, if we have polynomial on the numerator and denominator, we have to factor out first both numerator and denominator and find the common factor. Cancel out the common factor, which is x minus 2. So we have the remaining term 2x squared over x plus 2 because x minus 2 is being cancelled out. Another example, the factored form of the numerator is x plus 4 times quantity x plus 1. The factored form of the denominator is x plus 4 over x minus 4. Common terms or common factor from the numerator and denominator is x plus 4. Thus, the final answer or the simplest form is x plus 1 over x minus 4. Let us try another example. The factored form of the denominator and the numerator is common from their factors is x plus 5. Thus, the simplest form is x minus 2 over x minus 5. Next, y squared minus 3y over y squared minus 9. Using the common monomial factor on the numerator and difference of two squares in the denominator, we have the factored form. The common factor from the numerator and denominator is y minus 3. Thus, the final answer is y over y plus 3. Very good. So that is all about the examples and simplifying rational algebraic expressions. My little advice for you, my dear student, is to practice more to make it perfect. Good luck, everyone. Bye.